Hi everyone. Today I'll be doing an example of a question solve for acid base because uh, this topic is arguably one of the hardest calculation topic in the entire A-level chemistry syllabus alongside with kinetics. Yeah. So I will not be going through the basic of acid base like how to derive the formulas and all the definitions and so on. Because I think your school tutorial notes will have already provided you guys with you, for you guys a clear definition and so on already. And at this stage, so near to A level, I think going through this type of question will be more beneficial lah. So maybe next year I will be doing a more basic one for the new batch of J2s and J1s. Okay, so let's get straight to it. Okay, for this titration, it's a titration of a weak acid against strong base. So the weak acid here is methanoic acid. So it looks something like HCOOH again a strong base. Okay, so the key thing to every acid base calculation, if you think about it, what you are essentially doing is finding the pH at all points on the titration curve. Okay, so I will draw the curve here later, but let's just draw a random curve like something like that and like that. So what essentially what you're trying to do for every acid base question is to find the pH at to be able to find the pH at all point here and the corresponding volume used. So essentially that is what you're trying to do. And so I delete this here. Oh sorry, delete all of this. Okay, and let's get started. So let me zoom out a bit so that I got more space to write. So let's find the initial pH. Let's start off with the initial pH. Okay, and I just write over here lah. Okay, so for let me write down the equation first. So HCO2H dissociate into HCO2 minus plus H plus, or you can also write the equation with involving H2O, something like this. So plus H3O plus. Okay, so for let me just draw out an ice table for you guys to see what's going on. So let me just erase this equation because I think you guys will get what I mean already. Let me just erase this. Okay, okay, go back to ice table. So ice table. Okay, for those that you guys should know this by now, but ice basically means initial, change, and end. So the here I would like to put for concentration. So concentration initially of methanoic acid is 0.1 0 yeah 0 of this, and then you dissociate, so dissociate by a certain amount by x plus x plus x, then at the end the concentration is 0.1 minus x, yeah. And the equation Ka is KH plus HCO2 minus over HCO2H. Okay, let me just shift the board. I should actually I should just keep my handwriting a bit smaller. Okay. Okay, so uh the concentration of H plus is equal to the concentration of HCO2 minus, as shown by the X and X here. So and the concentration of HCO2H is approximately equal to 0.100. And let's just recap the assumption quickly. Because it's a weak acid, it low extent of dissociation, hence X the dissociated very little as compared to this. So X is much more than 0.10, hence 0.100 minus X is approximately 0.100 because you assume X to be very small or perhaps close to 0. Okay, so now you plug in all the value into the you plug in all the value into this equation. So you get 1.8. So I have already put the value here. Ka is 1.8 times 10 power negative 4. So 1.8 times 10 power negative 4 equal to h square. H is square because H plus is equal to HCO2 minus. So it's like H plus multiplied by H plus equal to square 1000. So H plus is equal to the square root of 1.8 times 10 negative 4 times 0.100. If you guys punch that into the calculator, you guys should get 0.00424426 mole dm cube. And then here you guys do your pH calculation. So pH equal to negative log 10, then 0.00424426, which is equal to 2.37. Okay, so this is initial pH. So for from now on, I will be writing log 10 as Lg lah, huh? Okay, so in order to know the initial pH is 2.37. I will go back here and let me plot it here. Okay, let me just agak-agak lah, huh? Okay, let me start here. 2.37, and then okay. So I will move this entire chunk to somewhere else instead. So if you guys want, you guys can pause the video and take a screenshot now. Okay, because I'll be shifting this away to make space for calculation. Okay, so let me just shift all of this away. Somewhere far away. Okay, let me just move all this away also. All this away. I can delete this nonsense. Alright, okay, so the next point that we want to calculate is what happens if I add 5 cm cube of add 5 cm cube of sodium hydroxide. So now first what you guys want to do is write down the equation, right, and see what happens when the NaOH is added. So HCO2 H plus NaOH, you guys form HCO2 minus Na plus plus H2O. So in this equation, you can the Na is just they are spectator ion, right? Spectator. So you guys can cancel this out to simplify your equation. So it will become something like this: HCO2H plus OH minus. Then you guys will form HCO2 minus plus H2O. Okay, so now let me just so here is your acid, is your conjugate base. Now you guys have a conjugate base. Let me just zoom out so got slightly more space. Okay, so you guys will want to calculate how much NaOH has been added. So NaOH added, I added 5 cm cube, right? 5 cm cube. So it's 5 divided by 1000 to convert to EM cube, multiply by the concentration of sodium hydroxide is 0.1. So I multiply by 0. And you guys should get 0.0005 mole. Right? Let me count. 1, 2, 3, 4. Yes, I'm correct. The number of zeros is correct. So, the number of hydroxide added, the amount of hydroxide added is equal to the amount of HCO2 formed. This because I try to go slightly slower here. This because all OH minus reacted to form HCO2 minus and HCO2H is excess. Okay, so right now it should make it be clear that there are no more OH minus. Okay, so hence at this stage, the amount of HCO2 minus is equal to 0.0005 mole. Okay, so at this stage, you use the Henderson Hasselbach equation, which states that pKa is equal to I'm sorry, my bad. It's not pKa, it's pH. Okay, so pH is equal to pKa plus log base 10 of the conjugate base over the acid. So in this case, your conjugate base is here and your weak acid is here. So I erase and I rewrite again. So here's your HCO2 minus, here's your HCO2H. Right. So now you will want to find the so you want to find the HCO2H left. Right. So initially you find the first initial number of mole present, and then you minus away how much got reacted with the OH minus. So you minus away 0.0005. You should get 0. Maybe 0.002 mole. Okay, so initially you should have 0.0025 here. Okay, so now you just have to plug in the numbers. So the video got cut off halfway. That was very weird, but let's resume. So now all you have to do is to plug in the numbers. So your conjugate base, plug in here. Your amount of acid left, plug into here. Okay, so far so good. Then now let's just solve for the equation. Okay, so we write pH is equal to pKa, as I've written in the question above in black, is 3.74 plus log over 0.0005 divided by 0.0002. Okay, so I want to highlight something important here. If you guys look at the equation, right? Oh my goodness, let's erase them. Okay, you guys look at the equation, right? See, this is concentration. This is the concentration. And what you guys have here are moles. So you guys still have to divide by total volume for it to be correct, although the volume cancel out. So here you guys have amounts, right? Moles. Here you guys have concentration. So in your formula, you just need to divide by the total volume. And in this case, the total volume is 30 cm cube divided by 1000 because you just want to put in SI unit, which is cm cube. And why is it 30? Okay, because we are adding 5 cm cube of NaOH to 25, hence the total volume is 30. Okay, then switch back to pen. So divide by 30 1000. And yes, it's true that these two numbers will cancel out lah. And although even if you guys don't include the total volume there, you guys will get the same answer. But theoretically, the volume should be there because it is in concentration. Okay, so you guys plug that whole chunk into your calculator. Your pH should be equal to 3.14, right? So let's go back the answer. Let's just circle. It's correct answer. So on this graph at 5 at 500, it should be somewhere I suppose here 3.14. Okay. Okay, now the same thing. Okay, please take photo of this if you guys have to. And yes, okay, now I delete all this so that we can make space for the next calculation. Okay. Okay, so for the next calculation, what we are, it's a very simple one, is we are looking at the half equivalence point. Half of equivalence point. So at half equivalence point, so the equivalent point is at 25.0 cm cube of NaOH, where all the acid reacted, right? So at half equivalence point, half is at 12.5 cm cube of NaOH. And at this half equivalent point, pH is equal to pKa. And for this calculate, you guys can remember this, which I think most of you guys will be able to. They could just immediately write down the answer, but just that don't. Let's go through the calculation together. So again, the Henderson Hasselbach equation. So the base over the HCO2 minus, and at half equivalence, half equivalence, half of HCO2 H reactor. So it means that this half here, they becomes the base becomes HCO2. So it means that the concentration of HCO2 formed is equal to concentration of the acid left. That's a really bad square bracket. Okay, so if they are the same, this means that they can cancel each other out, right? So this cancel out, then you get 1. So your Henderson Hasselbach equation would look something like this. pH equal to pKa plus log 1. And you know that log 1 is equal to 0. Hence, pH is equal to pKa to the 3.47. Sorry, 374. That's really bad. Just cancel 3.74. Then go back to our graph. Okay, this graph is going to be very disproportionate. 3.74. So this here. Okay, I didn't have to do that. And just like that. Times 0. Okay, we just draw a dot down. Okay, so please take a screenshot of this. You guys need to, and actually just erase this so I can rewrite nicer for you guys. Take a screenshot. You guys have to. So switch to red. Okay, so now I'll be deleting this, so you can move on. Okay, so for the let me get my notes out first. So for the next point, yeah, you guys want to calculate. Okay, let's say I add slightly more sodium hydroxide. Let's say I add 20.0 cm cube instead of the NaOH. How will the calculation look like? So this time round, the calculation will be quite similar to when 5 cm cube is added. So I'll be going through slightly faster. So now the same thing. You calculate and switch pen NOH reacted is equal to the base form, which is equal to 20.0 over 1000 times 0.100, and you guys will get 0.002 mole. And then you calculate the amount of acid left. Zero point zero zero two five minus 0.002 0.0005, and so as of now the total volume is equal to 45.0 cm cube. Okay, let's continue on. So now let's use a Henderson Hasselbach equation. I will go straight into it. Instead of writing out the format plus log, and then now you plug in a number. You plug in 0.005, and then you also plug in this number. So on top is your base, so you put 0.002 divide by the total volume, and just rewrite it. So 0.0002 divide by 45.0 times 10 negative 3 lah, to save space. Divide by 0.0005 divide by 45.0 times 10 power negative 3 to convert cm cube to dm cube. I just annotate it here. Oh, that's really bad. Okay, annotate nicely. Convert cm cube to dm cube. Okay, then your pH level should be 4.34. Okay, so now I go back this graph, and it's slightly before equivalence point, so let me try to draw it here. Here, okay, here lah. And we draw it up, 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 up. Here, maybe. Okay. Okay, you guys can take a photo and leave it here for a while. And let's move on. Let me delete all of this. Right. So let's calculate pH at equivalence point. So at equivalence point, all the acid reacted, all you are left with is only the conjugate base left inside the solution. So at this stage, the conjugate base will react with water, will dissociate to form back your acid and to form a OH minus. Okay, this equation would make more sense if you add in the water here. Yeah, because if not, the equation wouldn't be balanced lah. So let's get to the calculation. So for this equation, the Kb for the conjugate base is 10 negative 14 divided by Ka, which is 10 negative 14 divided by 1.8 times 10 to the power of negative 4, which should be equal to 5.56 times 10 to the power negative 11. Okay, so I will revise this quickly with you guys. So for this equation, essentially what we are doing is that because Ka of a weak acid multiplied by the Kb of the conjugate base is equal to 10 power negative 14. So to find the Kb, you simply just to take 10 power negative 14 divided by the Ka, and that's what I'm doing here. So let's go back to the question. Okay, so Kb then is equal to this H2O2H plus OH minus over HCO2 minus. Right. So at this stage right here, you guys have to be very careful about the concentration of uh of the conjugate base, because as of now, your total volume, right, is actually 25 plus 25 is 50.0 from burette, so cm cube. Okay, so this 25 is the original solution, and this is the NaOH added, right? So your concentration of your okay, let's do step by step instead of skipping. Okay, so your amount of conjugate base form, right, it is actually 0.100 times 25, and that is equal to the amount SC, right? So you guys still get 0.0025, but then the concentration is 0.00 0.25 divide by 50 instead of 25. Okay, so the I will not okay, let me just quickly key this in to the calculator. So we actually get 0.0025 divided by 50 divided by 1000, get 0.05. Okay, because I did not intend to go through this total volume thing. Yeah, because in my notes, yeah, I skip it. I lumped it into one equation, but I think it's better to break it down so that you guys can see it. So now, simply just have to plug it back into the equation. You have to plug this number, plug it back inside here. And here, your concentration of OH minus is equal to the concentration of the acid. And this explanation is same as the explanation of why at the start H plus and conjugate base is equal to each other. Hence, there's a H plus square at the start. So please go back to the start of the video if you guys don't understand what I'm doing here. OH minus equal to HCO2H. Okay, so moving on. So your KB 5.556 times 10 is equal to your OH minus squared, because the HCO2H and OH minus are equal to each other, over 0.05, and your OH minus is equal to the square root of 0.05 multiply 5.56 times 10 minus 11, which is equal to 1.6673 minus 10 negative 6. And then you guys go down, then your POH equal to negative log OH minus, which equal to negative log of this ugly number, which is equal to 5.778. And then hence your pH is equal to 14 minus 5.778, which is equal to 8.22. Okay, so 8.22. Okay, now let's go back to our graph. And you see that at 35, oh, this graph is legit super squeeze. Is 8.22. Okay, so we are very, very close to finishing this question. And I hope that this is helpful to show you guys how that you guys can really calculate all points on the graph using this. So okay, this is really long. So let's you guys can take a photo of this first. You guys need, and you can pause. Then you can go down here, pause, and you guys can take the photo. So now I delete all of this. Okay, so let's go to the last and final part before we conquer it all. So now I'll calculate what happens when 30 cm³ NaOH is added. So at this stage, right, I hope you guys that have recognized that NaOH is excess, and then the acid all reacted. Okay, so let me write down the equation again. So I will remove the Na here because there is an spectator ion. So So uh yeah, yeah. So what you have left at the end is all reacted, right? So you have OH left, you have HCO2 left in the equation. But at this stage, uh H, the conjugate base, has little effect on pH as compared to OH minus. So you can OH minus much stronger than HCO2 minus. So to calculate calculate pH, you can just consider the concentration of OH minus. Consider concentration of OH minus to calculate pH. Okay, so now let's do the calculation. So let's calculate how much NOH is extra, unreacted, and OH minus unreacted. Right, so since you added 30 cm cube divided by 1000 to convert to dm cube, multiply by the concentration 0.100, you minus the amount of acid at the start, you get 0.0005 mole of unreacted OH minus. And then you want to calculate the concentration of OH minus, which is equal to the amount divide by 55 cm cube 1000, and this 55 is equal to a 25 your original plus 30 of NaOH, so it's equal to 55. Okay, so the just key that into the calculator. What you guys get is 0.00090909 mole cube. So from now, it should be very obvious as what to do next. POH minus. Wow, that's really ugly. Sorry. POH minus is 2.04, and hence, it's not POH minus, it's just POH, my bad. So POH is 2.04, pH is 14 minus 2.04, 11.96. So this 2.04 is essentially just log 0.00900909. Okay, so now let's go back to the graph here. So at 30, your pH should be 11.96, close to 12. So let's plot the graph using red. So this is a half equivalent point. So the graph should go up like that, and then here it should slightly flat as it's a maximum buffering capacity. And then you go here, and then go straight up. Push. Oh, that's really bad. Let me try that again. So here it should become slightly flat, and then go back up. Here, straight up, and then curve up like that. Yeah, be something like that. Let me try right drawing in a smooth line. The shape should be something like that, straight, like that. Yeah, we get this much better. Although he's slightly curved. So here's your max equivalence point. Please label it. Max buffering capacity. And here is your equivalence point. Please label it as well. Okay, so this is all there is to calculating the pH at every level. So I will leave the screen here so that you can pause and take a photo. And I hope that this step-by-step video has helped you guys be able to understand and able to solve all these question and there is another hard part about acid base, which is making preparing a buffer solution. But preparing a buffer is has also the same core meaning, yeah, of balancing the ratio of the weak acid and their conjugate base, or the weak base and the conjugate acid. And so I will be making another video on that, hopefully before A level. And yeah, I really hope that this video has helped you guys, yeah, as much as how it has helped me, yeah, of the hours and me putting in the effort to understand this, yeah. So yes,